Well, hello everyone. Now, before I start talking about anything, I just want to let you guys know that my laptop at home is not working, so I need to fix it. Basically, what happened, the fan of the CPU stopped spinning, the temperature of the CPU is getting higher, you turn it on, it turns off by itself automatically. So that's a problem that I need to fix. So because of that problem, I'm going to have to record the class of today at my work, and I'm going to post it through Canvas, and you guys will have access to it. And this is going to be considered as the lecture of today. You have access to the video. You watch the video. You write your question, answers, notes, send me emails, and I'll respond to them. I'll make sure that this problem will be solved. So next week we'll have no problems. So today. We are going to talk about classes and objects. I'm going to go through the objectives and the requirements for this class. Remember here, this chapter, we are going to cover Module 2 in 2 weeks. So for today's class, we have in the ZY books around 20 points to cover. In this class today, we're just going to cover the first 10. And you will have access to the lab. So what I want you to do is once I'm done talking about those 10 points today, I want you to have a look at the labs and see which one of those labs are actually covered by those 10 points and see if you can actually answer those questions. Of course, it's up to you. If you choose to wait until we're done with the whole chapter to get those done, it's up to you. But I will highly recommend if you can get at least 2 of them done today, that would be great. So today we're going to talk about classes, objects, introduction to objects. We're going to talk about how do you create a class, of the using of the classes, how you define a class, member functions, mutures, accessors, and private helpers, initialization and constructors. We're going to talk about classes and vector classes. We're going to talk about separate files for classes. I'm going to demonstrate that as well. Choosing classes to create, and then the testing of classes. So those are the points that we're going to cover today. I'm going to be switching between the ZY book and Visual Studio during the lecture of today. So let's go ahead and jump into it. So we are going to go to module number 7 here. Remember here, everything here is basically just a review about what you had before. So we're going to jump into objects and classes. So I'm just going to click here, and I'm not going to go read this for you. I'm just going to talk about what is a classes, what is object-oriented programming, and all these kind of details. I'm just going to use this for headlines, but in general. Oh, and by the way, before I forget, all these tests and quizzes you can see here, they're not going to be graded, but it's a good idea to test yourself and test your knowledge every once in a while you're reading this. So I would highly recommend everybody to go through the materials of this chapter, just like I said here in the module 1. There is this reading assignments. That's what I want you to do usually before we get into the class. So now, before I start jumping and talking about the technical side of objects and classes, let me just go through some basic elements. Let me just grab some papers here. Okay, I know you're not going to be able to see this, but it's for me to organize my thoughts. Okay, so we know we can use what we call procedural style to solve problems. And procedural style to solve problems involve looking at the problem as one unit that could be solved in a term of steps. Each step by itself could be considered as a function. So for example, I want to get, for example, an object. Oh, let me just not choose an object. I want to get my phone moved, or my car moved from point A to point B. I think about the process in multiple steps. Step number 1, I'm going to call a tow car or tow company and they're going to send, I'm going to give them my address, and they're going to come and they're going to tow my car. I'm going to give them my address, and they're going to take the car to the next location. So my problem, I thought about it in a sequence of steps. What exactly I'm supposed to do to get the job done. Now, object-oriented programming, in the other hand, look at problems in a different way. What do we do with object-oriented programming? We basically consider and look at everything around us in a term of objects. So we look at the problem in terms of objects. We don't think about the problem at the beginning. We just think about the objects that are related to that problem. So for example, I'm part of this problem because I'm the owner of the car. My car is an object that's related to the problem, and the tow company by itself, it's a part of this scenario, and their car, the tow car, also is part of this scenario. So what do? We think about those elements, and then we start creating classes for each one of those elements. So I'm going to create a class for me as a person or the owner of that car. I'm going to create a class for the car. I'm going to create a class for the tow company, and I'm going to create a class for the tow car itself. Now, as you can see here, each one of those classes that I mentioned here, you're going to look at each one of them individually and treat it just like it is by itself without thinking about the other classes. So you're going to go and think about me, for example, as the owner of the car, and you're going to start describing me. Who am I? What are my properties? What are my attributes? What can I do? And all these kind of details, I'm going to start describing them inside the class that represents me. And then after that, I'm going to be moving on to another class, which is, for example, my car. That's another object. But before we get to move to the object, basically, I'm going to have to start thinking about the class of cars. What can I put in that class? What are the attributes of a class of a car? What are the properties of the class of the car? What can a car do? All of that will be described inside a class car. Right after you're done with that, you move on and you start talking about the tow company, and you start again creating a class for it, just like you did with the other classes. So once you're done with all the classes, you're going to start creating objects. So I'm going to create an object for me as a person. I'm going to create another object for my car. And then I'm going to create an object. Again, for each class, you're going to create an object out of that class. And you keep going. Once you're creating all these classes, right after that, you start thinking about how are these classes are going to interact with each other. Okay, that's something that you're going to have to think about. And how they're going to interact with each other, of course, to solve the problem that you are concerned with. And that's exactly what object-oriented programming is all about. So we don't look at the problem as a sequence of steps. What we do, we look at the problem as a group of objects which interact with each other, and their main job is basically to solve that problem when they interact with each other. And that's basically what we mean by object-oriented programming. Now, since we are a beginner here, most of the time, especially at the beginning, we're just going to create simple projects of one class. But before I get into that part, you need to understand the following. We write and we type classes, and from those classes, we create objects. Think about the class as a blueprint. Like a designer's for a car, for example, they will sit around a table and they will come up with a blueprint. In this blueprint, they will describe everything, every single detail about the car. So the class by itself is not the object. It's basically the phase of design for the object. You put everything you know about the class, about the car inside that class. And then after that, you take that blueprint, you take that class, and you create multiple, not necessarily one object, you can create multiple objects out of it. And that's basically what do we mean by objects and classes. So I found that a lot of students get confused between the two concepts. Think about the class as the blueprint, and think about the object as objects you created out of this blueprint. Just like when you go to a manufacturer, they have, for example, masks to create, let's say, toys, plastic toys. So that mask by itself, it's a class, and you can use that mask to create multiple objects, and those objects usually, they belong to the same class, so they are all cars or they are all toys, but each one of them by itself, for example, could have a different color, could have a different name, could have a different year of production. So you see, they all share the same class, they all have the same members, same variables, but the values of each one of them varies from one object to the other. So this is again what objects and classes is all about. Now, of course, it comes with a lot of details that we have to think about, and I'm going to go through them as we go. Now, when it comes to classes, there are some terminology and some object-oriented programming features that you have to put under your consideration when you think about classes. And the first one that you have to think about is what we call abstraction. So what is the meaning of abstraction? Abstraction basically means when you're going to create, like the concept of abstraction and information, details, and encapsulation, they all get mixed up. They're very, very close to each other. But in general, those three terms, abstractions, information hiding, or encapsulation, they all mostly mean when you're going to create an object and you're going to write a class, try to hide the internal details of those objects as much as possible from the user. You as a programmer, you need to know all these details. You have access to those details. You can change them, you can update them. But when you're going to create an object and you're going to give it to a user to use it to create objects, those details need to be hidden from those users as much as possible. Okay? Now, you may ask the question, why would I need to hide those details from the users? I'll tell you an example. Imagine you have a car and you're trying to sell this car to someone. Now, if I'll give you two scenarios and I want you to tell me or think about what would be the right answer for it. Now, imagine this car. Imagine this car. If I told you, okay, if you want to turn this car on, all you have to do is to press on this button. Okay, that's easy and simple, and you probably will be able to do it by yourself. But what I want you to do here is think about this. What if I need to teach you all the details and technical details about how the engine works just so you would know how to turn that engine on? Okay, right now, the first scenario, I'm telling you, press this button, the car will be turned on and the engine will be turned on. Or I'm going to give you a list of information and details and operations that need to be implemented for this car to be turned on. Of course, if that's the case, nobody will buy the car because, again, you don't want to give your users that much of details and headaches. They want something simple and want something easy. But of course, this is not the only reason why we hide details from users. There's another reason why we do that. And that reason is basically when you give the user the freedom to have access to the details of your car, in this case, or this object, they may do something that will ruin the whole object. For example, let's go back to the example of the car. You give the user 10 steps about how to turn the car on, and he have access to those 10 steps, and he's going to follow them, and he make a mistake, and then the car decided that it's not going to work anymore. Now, even though the instruction didn't follow your details, but it's going to be your fault, not him. So information hiding, not only you make the life of the people who are going to use your object a lot easier, but also you don't give the user access to some critical information that if they do have access to it, it may ruin the whole thing. I'll give you an example right now. Imagine you have a class. In this class, you have a variable, and this variable should have a positive value. If you don't hide the information from the user, this variable from the user, and you don't give the user access to this variable, if you give him access to that variable, he may end up mistakenly putting a negative value, and your whole program is going to crash after that. It's your fault because you give him access. So this is what we mean by information hiding or encapsulation, or abstraction. What do you do basically? You try to hide the details from the user for too many reasons, as I said. Okay, now, abstract data type basically, the whole concept of abstract data type is under this concept of data hiding. There's another thing related to this concept is, for example, let's go back to the car example that I was talking about, the person who needed a tow car. That person, basically, which is me in this case, stuck in the highway, and he needed that type of service. Now, maybe my name is important. I can include that. Maybe the destination, my house is important. But, for example, I do shop a lot, for example, for groceries. This is some type of information that's related to me. Okay? Now, the question is, do I really need to put that in the class? No, you don't do that. Why do you don't do that? Because, again, that piece of information, even though it's related to me as a person, but it doesn't have to do anything with the concept. So just because I'm creating a class called a person, that doesn't necessarily mean I have to list everything related to that person. No, you only take care and you only care about elements related to the problem that you're trying to solve. So this is what we mean by abstraction, information hiding, encapsulation. And here's just going to go with examples. You can read them, of course, if you want to. So now the question that we're going to go, and the part that we're going to move on after that is, how do we create classes? And what are the elements of a class? Now what I'm going to do, I'm going to skip looking at this example, which you can go ahead and have a look at it. I'm just going to go ahead and create a very, very simple class. Let me see if that's what he means here. Okay, so let's see here. What is he talking about in this chapter? Class construction. Okay, I'm just going to go ahead and create my own class. This is sorry. This part is to use classes. Now, in C++, whenever you want to use a class, there's something we call standard library, which basically is could be part of your project that you're going to create, and you can use those classes into your project. Here's just some definitions of some of these classes, but here's an example of one of them, which is the string class. Now, string by itself, it's not a primitive data type, and because it's not a primitive data type, someone thought about it before us and decided to create a class for it. And that class basically is stored in a header file called string. So that class usually will come with a list of data members and will come with a list of functions. We call them methods in this case. That's related to that. So during the semester, you'll find yourself, and this is something you have to think about, every time you want to do something in C++, ask yourself this question: have anyone thought about it before me? And I can guarantee most of the time the answer will be yes. And if that's the case, then just look and see if there's a library for it. For example, I'm going to go here and say include. All you have to do is just to know the name of the library, CMath. Now, CMath by itself, it's a huge library that comes with a lot of methods inside it. So, for example, I can come here, cout, and I'm just going to go ahead and type, for example, sqrt, and I'll put 81, and line. So you can see here, immediately the compiler was able to recognize what is sqrt. Now, let me just take this away, and immediately I should get an error. Come on, don't be that guy. Actually, that worked, surprisingly. Maybe CMath is automatically included, but for some reason I'm pretty sure it should not be. Let me just take it out again. Let me delete it. And let me try to see if I can ABS. Yep, it's included as well. So those functions, usually we need to use the CMath to be able to use them here, but for some reason, it's just, let me just give you another example in this case. Include, I'll dig deeper and see why is that okay. For example, I'm going to come here and say string. Not here, sorry. Here, string. and I will say name, and I will say Adam. Now, of course, this is acceptable, just like how the ABS is acceptable. But let me just type name here and see what's going to happen. Oh, this is weird again. So why do I need those header files anymore if they're going to be... What I'm trying to guess here, I think somehow they're included in my project automatically, because I'm pretty sure a long time ago, whenever you try to show a string, it will give you an error. But that's not the case anymore. Okay. Anyway, let me just take this out. What I'm trying to say here is, in a lot of cases, there is a class that has been already created to get something done for you. If you want to use it, you're just going to have to include that header file. But for some reason, the two examples that I was trying to do now basically didn't complain about anything. And that's a little bit weird for me, and I'm going to have to go and look and ask myself this question. Why is that the case here? So string are built into C. What enables a user to utilize string classes? This should be the right answer. And that's correct. It's not a built-in into C++. No, I know that for sure. Okay, so what I'm trying to say here is, again, in programming in general, there's always what we call the standard library. And your job is to basically try to find out if whatever you need is available in that standard library or not. If it's available, you just need to learn how to use it. Now, in this class, this is not the main objective of the class today. The main objective of the class today is how do you create your own class, and this is what we're going to be talking about next. But to be able to use any class, you basically need to include that header file that contains that class to be able to use it. Okay, so let's keep going. And let's go ahead and talk about how do we create our own class. And to do that, I am going to skip this section here, and I'm going to jump straight to Visual Studio. So here we go. This is my Visual Studio. Imagine I want to create a class. This class, I'm going to call it a point. So I'm going to say here, class point. This is, again, the syntax to create a class. You start with the keyword class. You name the class here, point. Let's put uppercase P here. And then you open a curly brace and you close a curly brace, and you need to have a semicolon here as well. Now, Visual Studio help you a lot when it comes to that. Just going to automatically add those semicolons to it. Well, number one, any class in the world will contain, well, that's not 100% correct, but elements inside a class, let's just put it that way, are categorized into many categories. And those categories are private, public, protected. At least for now, for this semester, this is what we're going to be focusing on. Private, protected, and public. In this chapter, we are only going to be talking about private and public. Protected is something we're going to be talking about later in the future. So, if you don't specify what we call the specifier, then everything is going to be treated as private. Now, you may ask the question, what is a private? I'm going to go ahead and talk about that in a sec. But for now, you just need to know that elements are private or protected, or public. If you don't specify anything, it's all going to be treated as protected. So, what do? We basically can come here and say public colon. Now, whatever I'm going to list in this area here is going to be treated as private, and whatever I'm going to list here is going to be treated as public. Even though you don't know what does that mean, let's imagine, but I'm going to explain in a sec. Now, I personally prefer to do it this way. You start with public, and you go at the bottom and put private. Okay? And this is a style that a lot of people actually recommend to use. So, members of this function are going to be listed here as public, and some members are going to be listed as private. I'm going to put some ground rules before we continue. Usually, not usually actually, always, all the data members are going to be private. And data members basically means variables that belong to that class. For example, when you have a point, how do you describe a point? Well, a point will have two coordinate values, the x and the y. Okay, we'll treat them as integers. So I could come here and say integer x, semicolon, integer y, semicolon. Listen, pay attention to this. In this part, I am just talking about private elements. Sorry, I'm talking about data members here. Okay, and I put them here as integers as a private elements. Now, why do I have to keep them private elements? I'm going to talk about that in a sec. Just let's go with it. And then public elements. Let me just tell you, for now, most of our public elements are going to be treated as all the methods that we're going to be working with are going to be treated, or functions are going to be treated as public. So a point will be described as two values, x and y. Now, this point basically will be associated with some functions. For example, I can have a function to what do I do with functions? Well, for example, I can have a function that will show me the values of the x and y for a point. For example, I can come here and I'll say void. Remember here, members of a class are two types. They could be variables and they could be functions. If it's a variable, we call it a data member. And if it's a function, we call it a method. So void print point. And this print point, what I'm going to do, I'm just going to put a prototype here. Okay, how is that going to be done? I'll talk about that later. But for now, we're just going to put a prototype. What else I can do to a point? I can move a point. Okay, so I can say void move. And to move a point, I need to know how much I'm going to be moving in the x direction and how much I'm going to be moving it into y direction. So integer, I'll say, for example, xd for x direction. And another integer, I will call it yd for the y direction. And put a semicolon here as well. Here's another prototype. So I can move a point. And I can print the values of the point. Let's just stick with those two functions, or sorry, those two methods for now. So here it is. This is me creating a point class. It's not completed yet because there's a lot more that has to be done. But let's just go ahead and see what else we can do. So this is my point class. As you can see here, we got public elements. We have private elements. Those private members are basically the integer x and y. And then we have a void method to print the point. And then we have a move method to move that point into the x direction or the y direction. Okay. Now, I need to implement those two methods. So right after you define those methods here, there are two ways. You can come here and define the method, which I don't recommend. So I'm going to go ahead and show you the other method here. So what I mean by that, you can take the semicolon and put the curly braces, start writing the code here. But again, this is not the recommended way to do it. So what was the recommended way to do it? I'm going to copy them, and I'm going to move here in this area before the main function. Now, all I have to do here is take those semicolons away and take this semicolon away. And then you can see here, well, this is a print method, and this is a move method. Now, what you need to understand, even though they share the name, this name and this name is exactly the same, but the compiler will look at them as two different methods. This one belongs to the class point, this one doesn't. So what we need to do, we need to tell the compiler that, you know what, this point method belongs to the point. Print point belongs to the print method. So what are we going to do? How do I do that? Well, the idea is very simple. You have to have the name of the class after the return data type. So it's going to be point, and you put colon here. And you do the same thing for the move method. Copy that, put it here. Okay? Now, let's go ahead and try to show those values. So I'm just going to say, show me x, put a space, show me y, and go to the next line. And for the move method, all I have to do is to update the value of x. So I'm going to say x plus equal xd, and y plus equal yd, and put semicolon. And here it is. I updated the value of x by adding whatever xd it was, and I did the same thing for the y. Okay, with that been done, this class basically is missing a lot. Let me just tell you that. But this is a very simple way to look at a class and how do you create a class. So the structure is very simple. The elements inside the class are very simple. And now we need to come to the part of why do I need to have private elements and why do I have to have public elements? Well, as I said before, most of the time the data members, the variables, need to be private. Why is that important? Because when you're going to start creating an object, you don't want the users to have direct access to those variables to manipulate them and change them as they want. Okay? We need to have some rules about what kind of values could be set to X and what kind of values could be set to Y. And since you're the programmer, you're the one who's going to set those rules. So if you give the user the access to those two variables, they may end up having some values that they're not supposed to have them there. And that is something that you have to pay attention to. So you are not supposed to give the user access to them. What do I mean by that? I will show you an example right now. Now, just imagine those two elements were public. Okay? Look what I can do. I can come here and let me just show you how do we create objects. To create an object, you have to start with name of the class, which is point in this case, and I'll call it P1. And I'm going to create another one, point P2. And here I can come here and say P1.x equal 10 and P1.y equal 20. And I can do the same thing here, P2.x equal, let's say, 9 and P2.y equal 12. Semicolon. Now he's not complaining about anything. And here inside the main function, I was able to change the values of X and Y for those two objects with no problems. Now imagine X should never be 10. Well, how can you control that if you're going to give the user direct access to it? So what we do usually, let me just put this here. I'm going to cut it from here and put it back as a private. Now since it's private, you can see now it's giving me errors. And if you put the mouse, it says, well, X is inaccessible. X inaccessible basically means you don't have access to it. Okay, I am good. It's inaccessible. I'll live with that. I can take that out now. Now, let me just show you what's going to happen. If I go here and say P1.print point and P2.print point, I'm just going to run it so you'll see the results of running this. Remember here, P1 and P2 are two different objects, but look at this. This is X and this is Y and this is X and this is Y. Now, a lot of people like to think those are random values. They're not random values. Basically, whenever you have a variable and it doesn't have a value, C++ will give it anything. As you can see here, the X for each case is the same and the Y for each case is exact. Well, actually, all of these values are having the same value. So what I'm saying here is, you need to find a way to be able to change those values. Okay? And that's what we're going to be talking about now. How do I change those values? But before we get to that point, let's just go back and talk about this private section here. We actually do put all the values that we have as private. Okay? Because we don't want the user to have direct access to those variables so they can change them and manipulate them as they want. We will give them a way to have access to them, but we're going to set some rules. So just in case the user decided to not follow these rules, well, whatever he's doing will not be acceptable, and we're just going to have to ask them to redo whatever they were trying to do to actually include an acceptable value. So what I'm going to do now, let me move back to the ZY book, and we'll see here we got private data members. We talked about that. Here it is. This is just an example. Here's some true and false questions. Defining a class as a public members. Okay, we talked about that as well. And this is just an example of a restaurant class. You can see here we got those variables. And here we go. So let's keep going. Okay. Now, let's go back, and there's something we're going to talk about next, but I'm going to do it now using the same example. Let me go back here. So, As you can see here, when I executed this program, the print points show me those random values for P1 and P2, X values. Think about this. Again, this is the class. Those are 2 points that I created. Each one of those classes will have an X and Y value. Okay? And now my question is, well, how do I change those values if I want to? Well, the idea here is very simple. You can change those values by using what we call setters. A setter is a method that is public, and that method would allow you to change those values. So a setter usually would not return anything, so it's going to be void. And we go to set X, and you have to pass X. I'm going to put new X. And then after that, I will say void set Y, and I'll create another integer I'll call a new Y, semicolon. Now, just like what we did with those 2 methods, we're going to have to repeat the same thing here. Okay, so let's go ahead and do that. And now I'm going to copy those, just like I did before. And I'm going to put it here. And let me just put this one here. Okay, set X and set Y. Take the semicolon, of course, and take the semicolon, of course. Now, let's just imagine for 1 second, X should never have the value of 0. Okay? Should never have the value of 0. So what I'm going to say here, if, this is how I control the value that's going to be set to X. So I'm going to come here and say, if new X equals 0, or let me just put it this way, doesn't equal 0, then you can go ahead and say X equal new X. Now else, if that's not the case, well, just show a message. For example, X will not be changed. It will kept its value. I'll just get cout X should never be 0, \n, and put semicolon here. And what I'm going to do the same thing for the Y. So let me copy that. And I'm going to put it here. And I just have to change this to be Y. And I will just have to come here and say Y equal new Y. And I will just come here and say Y should never be 0. So now you can see here, I do have 2 methods that will give me access to X because they're public. And now if the user decided to have access to X, they can do that easily. For example, let's go to P1. I'll say P1.set X. And I will say, for example, 10. And put semicolon here. And I'll do the same thing here. P1.set Y equal 20, semicolon. And for P2, I can come here and say P2.set X equal, let's say, 100. And P2.set Y equals 0. Okay, now it would be a good idea actually to have a default value for X and Y, but I'll just go ahead and leave it for now. Let me run this now and see what's going to happen. And look at this. Oh, wait a minute. Yes. Why am I having this message here? Because I try to set Y to 0. But here it is. This is P1, 10 and 20. This is P2, 100. But for PY, since I couldn't change the value of Y, so it kept it as it is. Let me go back here and change Y here, for example, to be 200. And let me run it. You will notice that they both have those values. So you can see here, creating those variables as private basically is a good idea as long as we do create them as a private element because we don't want the user to have access directly to them, so they can actually, if the user decided to set those values to anything they want, we do have some rules here that can control what kind of values are acceptable and what kind of values are not acceptable. Now, what if I want to show them inside the main? For example, I want to change, just imagine, I want to change the value of X here. So I know that I cannot, no, let me just put it this way. What if I want to show the value of X? So P1.X and line, something like that. Oh, sorry, not set X, I said X. Okay, immediately we got the same message here. You cannot have access to X. It's not accessible. You cannot show it. You cannot change it. You cannot do anything. So because of this, again, trying to have access to it, to show it, to use it, what I can do, I can also have another type of method. We call them getters. Now, a getter is different than a setter, but they look alike. Number one, a getter will have a return data type, not void. Since X is integer and Y integer, so it should return an integer. So integer, get X, put semicolon here, and integer, get Y, put semicolon here. Now notice here, there's no arguments that need to be passed. That's very obvious because I don't really need to pass anything. I'm trying to get something. And whatever I'm trying to get in this case is integers, so you have to put them as they are. So let me copy this. And I'm going to go down here, and just like we did with the setters, take the semicolon away, and put a curly brace, and put another curly brace here. And of course, you have to tell the the compiler that those two methods belong to a class called point. And the idea here is return X. That's all you have to return. And this one, return Y, and put semicolon here. Okay. Am I done? No, I am not done. Now, what I'm saying here is, I can come here now and type get uppercase X for P1, and I can do the same thing for P2. P2 get X and P1 get X. So now I can have access to those X using those getters. And again, just remember, this is if you want to have access to them. Okay, so let me run it. And here we go. This is the X for P1, and this is the X for P2. Okay, so this is, again, this example here, which I'm going to upload, is a very simple example of how do you create a point, how do you create a class, what are the public elements, what are the private elements. Now, just because the public elements are methods here doesn't necessarily mean that all the other public, you cannot have public method as private. Actually, you can do that. Well, you just have to put into consideration, are you going to actually how are you going to have access to them? Usually, you must have a method inside public to give you access to that one. Otherwise, it's going to be inaccessible. Anyway, so here we go. This is the implementation of these methods. Remember, here you need to put the name of the class, and then you put the name of the method, and then you do the implementation here. What's very important here to understand that when I created P1 and I created P2, each one of those methods must have X and Y values. Okay, so P1 will have an X value and Y value. P2 will have an X value and Y value. The idea here is they have different values. They could share values, of course. That's also acceptable. Now, let me just give you one example here so you understand. Imagine I created a class called students. And I create an object student number 1 and student number 2. Each student will have an ID number, but they're going to be different. Also, at the same time, each student will have, let's say, a name. A name. And they could have different names, or they can have the same name, like same first name, Adam and Adam. That's possible. But what you need to understand here is student number 1, which his name is Adam, and there's a student number 2, which his name is Adam. Both of those Adams are not the same person. They're two different objects that happen to belong to the same class, but they share the same name. So this is how you should think about these objects and those data members and what do they mean. Okay, now with that being said, we can go back to ZY books, and here we go. These are just examples of what I've been talking about so far. You can always have access to this and read them and go with those exercises to see how do they work. Okay. Let's keep going. What's going on here? Those are, again, just examples of what I've been talking. You can always have a look at it, the one that I gave you. This will be a really good idea too. Exercise if you want to have a look at them. Okay, so let's go ahead and look at the second part or segment. The inline member functions. What do we mean by that? Let's see. Member function. So this is my class. This is my class. Public. Fact1. Private. Public. Oh, I see what's going on here. In this part, they're just telling you that you have two options when it comes to the implementation. And I'm going to show you what we mean by that in a sec. So let me go back to the Visual Studio. Oh, I already showed you that. You see here, this is the part what I was talking about here, the inline implementation. Inline implementation of those methods basically means instead of having the implementation outside of the class, you can have them inside the class. That's an option. So what do I mean by that? I can copy this, for example, and I can come here, take the semicolon, and put this here. That's okay. But of course, if you do it that way, then you don't need this anymore. So I'm just going to take this one away just to show you that you do have those two options. It could go this way, or it could go this way. You do have those two options. And that's what we mean by inline member functions. You can implement them inside the class, or you can implement them outside of class. Why is this more recommended, the outside of the class? Is because later on, you're going to be creating multiple objects, multiple classes, and each class will be in a different file. So to have a better, or your project will be better organized if you follow this strategy and this method. Okay, now we're going to be moving on to the second part, which is I already talked about it. We got the mutures, which basically means those are the getters that will return the data type, and we got accessors, well, basically that will give you an access to modify those data members. And I showed you an example for them, and here they are: set name, set rating, get name, and get rating. Remember here, look at those getters. The getter is always going to return something, and then you have to tell me what is that data type. Now, some of you may notice that there's a constant here, which basically is something that I need to talk about. So that'll give you an idea. What is the meaning of having a constant in this area here? Okay. Let me go ahead and explain that. Let's go back here, for example. Set. Or let's talk about the get. If I come here and type constant, and I come here and type constant, of course, if I'm going to type it here, I need to go ahead and do the same thing here. Where is it? Constant and constant. Okay, now what does that mean? That basically means, remember here, this is extremely important. If you put the keyword constant after the closing parentheses of the name of the function, that basically means inside the body of this function, the data member, in this case x and y, you're not allowed to change them. Okay? Put that in your consideration. So this is, again, if you don't want to change them, it's okay. But this is basically a way to pass a message to someone. Tell them, you see, in this function, you're not allowed to change the data members, which is x and y in this case. So let me just show you what I mean by that. If I come here and say x equal, let's say 100. Okay, immediately you're not allowed to change the value because you decided to go constant. Okay, so what it's a practice. Whenever you have this list of functions, you're gonna have to ask yourself this question: in this print point, am I gonna try to change the values of x and y's? And if the answer is no, then type constant. Okay, this is a way to tell whoever is going to come after you, for example, to read your project and work on it. Let them know that, oh, you're not allowed to change x and y in this area. This place area, basically, you will be able to use x and y for calculations, for showing, for anything, but you are not. You're forbidden from modifying it. Move. Now, look at move. If you go to the implementation of move, where's the move implementation? Here it is. Oh, I actually am updating values of x and y. So I'm not supposed to put constant here. Set X, I'm changing X. Set Y, I'm changing Y. So I'm not supposed to put constants here. But here, since I know I'm just going to return X and I'm going to return Y, then I will put constant here just to let whoever is using your project to know that you're not supposed to change the value here. And if you try, it will give you an error. Sometimes some functions, you know, the value should not be modified. Sometimes you know some values must be modified. So again, it's a kind of practice that you have to think about whenever you create a function. If you know the values of the data members will be updated in that function, then don't put a constant. If you know for sure that they should not be updated, then you put the keyword constant here. And this constant basically means this X and this Y should not be modified here. Okay, there's another constant that you may see in the future, which is, in this case, constant integer new X and constant integer new Y. Now, of course, this is going to cause some issues when it comes here. So I'm going to say constant, and the same thing here, constant. So what does that mean? Well, if you put constant here, that basically means new X is a constant, and that basically means new Y is a constant. So if you go to the implementation of those methods, if you try to change new X here for some reason, it will not be acceptable. You cannot change it here. So new X and new Y will be treated as constants. So this is the main difference between having the constant after the parentheses or having the constant inside the parentheses before the declaration of your argument. Okie dokie. So this here is the part of the constant, and this is basically we're talking about the muture, accessors, and private helper. Okay. Now, the second part is extremely important. And I'm going to go ahead and talk about this. Initialization and constructors. So what do we mean by that? Well, he decided to mention DMI here, so I guess I'm going to go and talk about DMI. Did he? Well, even though he mentioned it here, but he didn't actually use it. Just give me 1 sec. I'll be back. Okay, so let's go back here. Let me just look here. Since he mentioned in member initialization, data member initialization, he didn't talk about member initialization list. This is something that's going to be covered probably later, but I'll just talk about it right now. Now, let me go back to the project that we created. Now, you remember before we have those setters and getters, let me just comment this section, comment this section, comment this section, comment this section. And yes, comment this section. Well, let's just leave this section here. Now, if I run it, come on, you see those values that we were talking about. Now, of course, because I don't like those variables, they're not exactly what I'm hoping to have. We had to use those setters to be able to change them, which is okay for now. Okay, but here's the deal. We have a tool that we can use, and I'm not going to talk about member initialization list. I'm just going to wait for the right time for it because it's a little bit more complicated than I originally thought about it. So I'll just leave it to that point right now. So we have a tool, or we have a way that we can actually assign values to those variables for each object automatically. Okay? And to that tool that we have is a very, very special tool, and it's a kind of tool that you must have in any project you will be working on. So let me just tell you what is that tool called, and it's called basically Constructure. So what is a constructor? A constructor is a method. Let me just put it in this form. It's a method inside the class, and it must be public, and it must have the same name of the class, and it doesn't have a return data type. Okay, so those are it's a method, it's a public, it has the same name of the class, and it doesn't have a return data type. And by not having a return data type, I mean even void is not acceptable. Okay, this method is going to be called automatically when an object is created. And we usually use those methods to set some default values to the data members that we have. So let's go ahead and have an example. So first of all, it's a public, so this is where I'm going to put it. It has the same name, point, and it doesn't have a return data type, so I'm not typing anything here. And here it is. So this is my constructor. Now, constructors, again, as I said, they are used to assign default values to, not default values, sorry, to assign values to the data members. And I'm going to show you that we have many different types of constructors. So the first constructor is what we call a default constructor. And the default constructor is going to be used to assign default values to those variables. So default value will be assigned to those variables. Okay? So in this case, let's go look at this point here. Copy that. And I'll say point, first of all, name of the class, and then the name of the method. In this case, I'm going to come here and say x equal, or I could do this. I can say set x, and I will just pass the value. What will be a default value? I'm just going to go 10 by 10. Since I decided that 0 is not acceptable, so I'm going to go 10. I'm going to do the same thing here. Set of y to 10 as well. Now, just to let you know, oh, this is set. Just to let you know, this is also acceptable. X equal 10 and y equal 10, but it's recommended actually to use the setters as much as possible. Okay, so this is what we call a default constructor. Now let me show you what's going to happen. If I take this one away and this one away, and I take this one away, now if I run it, why is he complaining about P1? Okay, let me run it, and look at it. Default values 10, 10, 10, 10, 10. So what happened here basically, when I created P1, automatically this method was called, and x was set to 10 and y was set to 10. And the same thing happened when I called P2. So both of them were created at the same time, and each one of them will be set to those default values, 10 and 10. Okay, sounds good, looks good, no problem with that. Now, what if I don't like 10? What if I want to give them values? Well, this is where we have what we call argument constructor. So I'm going to come here, and I'm going to put the same definition, but this time I'm going to have a new x, an integer new y. Okay, so this is what we call an argument constructor. You need to understand some facts here. When you call a default constructor, as you can see here, I just put the name of the object and I'm done with it. Now let's see, how do we implement this method here? So I'm going to go down in this area, and I'm going to put this here, and now I'm going to copy this part just like it did here, and then I'm going to take this semicolon away, put this part here, and then I'm going to copy this part here. Let me copy this, and I'm going to put it here. Okay, now instead of passing 10, I'm going to pass new x, and instead of passing y, I'm going to pass new y. Of course, let me just tell you here, you can come here and say new x equal x, and you can say new y, y equal a new y. Now this is not recommended to do it this way. Why is not recommended? Because what if the user decided to pass 0 here? Well, if the user decided to pass 0 here, then if you go with this technique and this technique, then x and y will be set to 0. But you have a rule that they're not supposed to be set to 0. Again, there's no reason for this rule, but I'm just telling you, I came up with that rule. I don't want x or y to be set to 0. The center should not be occupied by any point. Okay, so if that's the case, you should go and use the setters. Now let's look here and see what's going to happen. If I come to point 1, and I'll say, for example, 2 and 7, and if I go here and put, let's say, 9 and 3, Now you can see here, let me just show you the difference. Whenever you want to call the argument constructor, as you can see here, then you basically have to pass arguments. Same thing here, you're going to have to pass arguments. Now if I run it, there will be no problems. You can see here 279329. Okay, it works perfectly fine with no problems. Okie dokie. So this is the default constructor, and this is the argument constructor. And the default constructor will assign the data members to default values, and the argument constructor will be assign those variables to values you are going to decide. In this case, the new x and the new y. Okay, we have a third type of constructor. Let me just see here. Overloading, comparison operator, overloading. He didn't talk about that. Okay, we're doing good. Let me just keep going. This video is going to be a little bit long, but it's okay. So let's go ahead here. We got the get, we got the constructor. I'm going to talk about the third type of constructors, which is what we call the argument constructor. And a copy constructor. And a copy constructor basically will have, look at this. This part will have, let's see, why is he complaining about the point? I think it should be a reference. Yep, should be a reference. It has a reference to an object that belongs to a point object. So what does that mean? Let me just go ahead and show you what does that mean by implementing it. And I'm going to go down here. So remember, point, colon, put this here, take the semicolon away, and put this here. Look what I'm going to do. I'm going to say, this is a little bit complicated, set x, and I'm going to come here in this area, and I will say other dot get x, and put semicolon. And I do the same thing with y. Set y, other get y. Okay, so what does that mean? Well, the idea here is very simple. The idea here is very simple. Let's go ahead and show you an example here. For example, if I come here and create a new point, and I will say point P3, and I'm going to pass P1 as an argument. Okay? So what's going to happen? P1 is going to be passed to other. And here I'm saying set x. So I'm trying to set the x of P3. And what is the value of the x of P3 is going to be basically whatever the x of other is. And this is where the what they call the copy constructor comes from, because I'm copying this object to the new object, which is P3 in this case. So this is basically what we mean by copy constructor. It's the fact that I can use the data members of another object to be assigned to a new object, which is in this case P3. And those are the three types of constructors. We have something called overloading constructors. This is the case for overloading constructors, by the way. And overloading constructor basically means, just to give you an idea, is having three different methods that share the same name. That's basically what any overloading functions will look like. So if you look here, we got point, we got point, we got point. Now, whenever a function of those are called, the compiler will look at the arguments. So when the compiler is going to look, for example, I don't have it here, but let me just go ahead and do that. Point P0, for example. The compiler will look and say, oh, there's no argument, so this is the default constructor. Oh, there are two arguments, so that's the argument constructor. And oh, here, there's an object, so that's the copy constructor. So the compiler here, this is a case of what we call overloading constructors. Okay? So let's keep going now and move back to the ZY book. So everything I talked about here is covered here. Let's go ahead and keep going on. Classes and Victor classes. I'm guessing here, yep, Victor. We talked about Victor the other day. Here it is. And this is a review class. And what do we have inside the review class? Private, integer, -1, string comment. And by the way, when you create a private members and you give them values the way you see it here, this basically means this value is going to be initially assigned to the values when you create an object, even if you don't have a constructor. So we have a function here called set rating and comments. Okay, I'm trying to figure out where's the Victor in this whole thing. So it's a Victor. Oh, okay, I see what's going on here. You can create a Victor of objects. So what I'm trying to say here, just like I created 3 points, what I can do, I can create a Victor of type of points. So let me just go ahead and show you what do I mean by that in a sec. Let me go back to the here. Instead of me creating those 3 points, I can come here and do this. Victor point. Okay, I'll call it my points. Okay. Now, of course, he's complaining because I need to include the header file of Victor's. So I'm going to go ahead and do that right now. So let's go ahead and type include Victor. Okay, now he's not supposed to complain about anything here. What I'm going to do here, since I have P1, P0, P3, P3, I'm going to come here and say my point dot push back, and you push P0, for example. So P0 is going to be pushed into this Victor. Same thing here. You can repeat the same thing with P1, P2, and P3. Again, this is not a big deal. It's just to tell you that instead of having multiple objects, each one of them independently, you can put them all together within one Victor, as you can see here. Okay. Do we do that? Yes, we do that mostly a lot. But again, this is an option. You can leave them as objects, separated objects, or you can put them all together within one Victor. So here we go. This is just to show you an example of the possibilities you have to do that. And these are just extra examples that you can see here. There's a lot of Victors that you're just adding and adding using the review. Again, this is just an example here. Separate files and classes. Now this is the part where you need to pay attention to. And I'm going to demonstrate the same concept using the point that I created before. So you can see here, this my point class here, I ended up having one file with 87 lines of code. Now, what you need to understand here is, in general, classes are complicated and are long. So to keep every single project into one file, that's not a good idea, especially when you have multiple classes. So here's what we're going to do. I'm going to put this project in 3 different files, and I'm going to show you the process for that. And I want you to pay attention to this. So number 1, you go to the header, right-click here, add, new item, and then you go ahead and create a header file. Now remember here, the name of the header file should match the name of the class. Now, is that 100% necessary? No. If you don't follow it, it's going to work. No syntax errors, but it's recommended to do it this way. So here we go. We do have this header file. Now, once you have this header file, which has the same name of the class, what I can do, I could come here and cut this class from here. Now, am I done? Nope. Let's just cut it for now, and I'm going to put it in this area. Now, of course, more need to be done. So the first thing we're going to do here, we're going to come here and say if and diff. If not defined, and you type POINT uppercases underscore H. If there is no class called point and it's not defined, then define POINT underscore H. And then the last part is to go at the end here and type and if. And this and if is basically for the end of this one. And now it's gone. So here we go. This is me creating this header file. Okay, the name of the header file should be the same as the name of the class, and you need to include those directives at the beginning of it. And this is, again, the reason why we have those is just basically if it happened that there is a class in the standard template library that share the same name, then go ahead and use the standard template library. But if there is no header file with the same name, then go ahead and use mine. Okay, now since I'm going to be using those header files during my project, I'm going to cut them from here and I'm going to put them here in this area. Now, one of the things that you should know, even though it's acceptable, you can put some implementation inside your header file, but it's not recommended to do that. It's recommended to separate those files. It's a better idea for having a better control, or better. It's a better way to organize your project. So here's what I'm going to do. I'm going to copy this. I'm going to go back here and put it here, and I'm going to use the same thing I did here. Copy this C and put it here. Okay. And what I'm going to do, I'm going to come back here and take this and delete it and replace it with the semicolon here. So I am done now with this header file. And you can see here I got point class, and I have my directives, and I have everything done here. Now, once I'm done with this part, I'm not done yet. I need to create another file. Now, this another file, you can put it in resources or you can put it in sources. It doesn't matter. I like to put it in resources. So I'm going to come here, create a new item. This time is going to be a CPP file. But what I'm going to do, I'm going to call it point CPP file. Now, remember here, if you don't follow these names, it's still okay, but it's better to give it the same name of the class. And here we go. Now, let's look and see what's going on here. I have a CPP file. I have I have a point CPP and I have a header CPP. What I need to do here, this is extremely important, just type include double quotations and type the following. Point.h, the same name of this header file. You put it here. Now, we could come back here, cut all these implementations. All of this, cut it from here, and you put it in this area. This is what we call the implementation file. Okay? So let's go back here. This is my header file where I defined everything. This is the implementation file where I am going to define the implementation of everything. Okay? And I'm not done yet. Okay, now I'm done with that part. The only part left here is in this area, just like how I included the header file of point, I need to include that header file also here. And now I have my project in 3 separated files, as you can see here. And that basically, it will work perfectly fine. If I run it, no errors, everything will, oops, no copy constructor. This is weird. Where is this coming from? Let me close this. This is weird. He's complaining about a copy constructor. I don't have a copy constructor. Here it is. And I have it here. Well, he should not complain about this. Class point, no copy constructor available, or copy constructor is declared. Okay, I'll take that out. If that's what's driving you crazy. Looks like a lot of things changed in C++ recently. Let me run it again. Okay, that works. Okay, now the last part I forgot to mention here is something very, very important. In addition to having those constructors, you have to have something we call destructures. And the destructures is a function that will look like this. Point and put parentheses, semicolon. Now I have to implement it, of course, so I'm going to copy it from here and go here, point, colon, colon, and then take that out and leave it empty. A destructure is a function that's going to be called when the object is destroyed. Basically means by the time the program is done implementing. Now, why is it important to have it even though it's empty here? Because if you don't have a destructure, the space that were reserved for each object is going to be there and it's not going to go away. And because we actually that basically means that the reserved space inside the memory will not be removed from the memory, and that space will not, the computer will not be able to use that space for next programs until you actually restart your system. So what we like to do usually is to this is what we do usually. We have a destructure, which basically means free the memory when that object is executed. Now, for now, we're just going to leave it as it is, but later on we will see that you actually need to put some code here. But for now, just leave it as it is. Okay, so here we go. This is the part where we talked about initialization. No, what is the part here was? Separate files. Okay. So we talked about separated files. Now, only 2 parts left to go, and I'm going to be done with this video. Choosing a class to create, decomposing into a class. This is just, you can go ahead and read it. It's not a big deal. There's no technical elements here, including files. Okay, those are, I think I mentioned everything here before. So the last part is unit test. Test cases. Yep, every time you create, this is one of the things you have to think about. Every time you create a class, you need to actually test it and make sure it works perfectly fine. Test all the methods. This is something I'm going to ask you to do. When you create a class, you need to actually give every single method of the methods you created a test, and not only test it with one value, test it with multiple values to see if your system will be able to work with no problems, even when even with different types of and different values, just to make sure that you will have no problem with that method. And that's basically what we mean. Again, I will highly recommend everybody here to go and read the last 2 elements here in this book, just to go through those elements and make sure you understand those concepts. So this will be the end of this video. And again, I am just going to repeat what I said at the beginning of this video. My computer doesn't work, and I'm going to try to take it and fix it. And because I don't have a computer at home, I had to record this video at my desk at my office today. This problem should be fixed today. I will go back home and try to see what I can do. Worst scenario case, I'm going to have to buy a new one for next week class. So this will be the end of the class of today and the video of today, and I'll see you guys later.